we're doing what? Which number?
Number 1.
Okay, guys. Number 1. Wait, number 1?
Yeah.
Okay.
Sometimes my brain just hurts itself.
Okay, so that's number 1. So you see it. Okay, can you tell where they those graphs met?
0 and pi, I believe.
So
But it's no, it's just a graph.
right. Okay, sorry, it's a little not symmetrical. Okay, now let's see here. With the cosine squared business, is that what you meant? How to use?
Yeah, how do you integrate cosine squared? If we did u substitution, then d
Yeah.
would equal negative sine x or dx. Yeah, negative
How
sine
could you?
x.
I thought it was cosine when I signed it. I think that it's the same as one actually the cosine, but what number is this? 1?
1.
Oh, dang it!
That is definite.
No,
No.
I should have told you that before.
Oh shoot, yeah, that's the trig identity, isn't it?
It is the trig identity, and I would normally tell you that. This is from pre-calculus. We have these trig identities we memorized. 1 minus cosine squared is the same as sine of 2x. Okay, so no, you wouldn't have known that. All right, let's do it together though.
Sine squared.
Hmm.
Sine squared, isn't it?
Oh yeah. Why is it sine 2x? No, it's 1 minus 2 cosine squared.
Are you thinking of that?
No, double angle is 1 minus 2 cosine squared. Well, sine squared wouldn't help us at all. 1 minus. What?
That's the same thing that my mind was doing right there.
Yeah, I don't know. I'm sorry. When I looked at it, I thought it was cosine, just a cosine curve.
Yeah, it was.
I apologize. Okay, let's scratch one. And what other
You
one?
can just use fn int on that?
Yeah.
Okay, great.
2 you used fn, correct?
Yeah,
Okay.
after I tried solving it back here.
Wait,
I said you could use fn int on number 2. Should we do like number 3 a minute, or?
yeah.
Okay. Just as an example of what we did yesterday. Okay, so in number 3, you had the y or x equals y cubed. And then x equals y squared, which is just actually, we'll talk about what those, and they meet at 1, 1. Okay. So there's a couple ways that you can do this, and this is one. Since you have your curves already defined this way, you could flip this around and integrate with respect to y. Do you see how they're already defined by y?
Yeah.
And integrate on the y-axis? Or you could solve these as a square root and the 1/3 root and solve on the x-axis. Okay. This is what you were asked to find, correct? What I'm going to do is I am going to solve, I'm going to do this way. That'll be a good way to introduce when you have things defined for y. Okay. So I'm going to integrate from 0 to y. Now, I know that seems weird, but, because it looks like I'm going to the left, but I am going in the positive direction because I'm going up, okay? So, are you guys okay if I turn it this way so we can see it?
Yep.
Now, if I'm finding the difference between the curves here, I have to find which one is above the other. And it looks like going this way isn't the y squared above the x cubed. So I'm going to be finding the difference between y squared, y squared minus, did I say x cubed?
Yes.
Sorry. Sometimes I don't even hear myself say those things till later. And we're doing with respect to the y-axis. So a long time ago, we had conversation about that dx business, and now you can see why you should tell what you're integrating with respect to, because now I can do it with y-axis. All right, can you guys integrate y squared minus y cubed for me? Yep. From 1 to 0. So putting 1 in, this would be 1/3 minus 1/4, correct?
Which is 112.
And then minus 0. And yes, finding a common denominator, this is 1/12.
You always have to put minus 0.
Kind of like, do you always have to put 0? Sounds like something my kids would say. Do I always have to eat my vegetables?
Well, I'm pretty impressed that you did that. That is just a big brag. I mean, yeah, that's